Good afternoon, everyone. Welcome to this American Society of Civil Engineers, Wisconsin chapter and League of Women Voters Infrastructure Report Card. Today's webinar, which is the fifth webinar in this Wisconsin infrastructure series, will discuss Wisconsin's drinking water and wastewater infrastructure. I am Ann Battiza, a former vice president of the League of Women Voters of Milwaukee County, and I'm delighted to be your moderator today for four excellent speakers. They will discuss Wisconsin's water infrastructure, which received E, and our wastewater infrastructure, which received a D+ from the 2024 ASCE report card. Our presenters today are Justin Bilskemper and Deanna Branch, addressing Wisconsin's drinking water infrastructure, and Jen Hurlebaus and Kevin Schafer reporting on Wisconsin's wastewater infrastructure. Please add your questions to the chat for a Q&A at the end. Our first presenter today is professional engineer Justin Bilskemper of Strand Associates Incorporated in Madison. He was the lead author for the ASCE report card chapter on Wisconsin's drinking water infrastructure in both 2020 and 2024. Welcome, Justin.
Thank you. I'll go ahead and share my screen. Get it right this time. Okay, we good to go?
Perfect.
Awesome. So thank you for inviting me. Pleasure to be here to talk about the drinking water chapter that that I was able to help produce for the ASCE Wisconsin section. I won't, I guess, maybe give an introduction about myself since Ann did it here for me. So a brief introduction before we go into some of the key criteria, some of the key takeaways here is that the report card committee gave the drinking water section or chapter rather a grade of C. It's a slight improvement over the 2020 report card, which was a grade of C-, mainly due to influx of funding that was recently available here over the past 3, 4, 5 years. Wisconsin has more than 11,200 public water systems, which is actually the most in the nation. They're generally encountering several natural man-made water quality issues. They must contend with aging water treatment and distribution systems to serve communities in the future. Some of the common or significant water quality concerns would include bacteria, nitrates, arsenic, radium, lead, PFAS, forever chemicals. I'm sure everyone here has heard of these things. And I apologize, it keeps moving on me. In total, the US EPA, United States Environmental Protection Agency, estimates that almost $12 billion is needed to address infrastructure in the next 2 decades. And these needs will likely increase over time unless immediately addressed. As I said before, the recent increases in drinking water infrastructure funding through the bipartisan infrastructure law or bill or the Infrastructure Investment and Jobs Act or the IIJA, it's laudable, it's commendable, but it's insufficient to serve residents to have better access to safe and reliable supply for future generations. So a little bit here about drinking water capacity. As I mentioned, there's more than 11,200 public water systems serving nearly 4.24 million people. All of those water systems are regulated through the DNR. However, a vast majority of those are, those are considered transient, non-community water systems. Think like, sorry about that. So 56 of these systems rather are surface water, and they include some of the largest communities in the state, including Milwaukee, Green Bay. They supply almost 1/3 of the state's population, while the groundwater systems consist of more than 99% of all the rest of the public water systems. In general, drinking water capacity is in Wisconsin is adequate with plentiful access to groundwater aquifers and surface water supplies such as Lake Winnebago, Lake Michigan, Lake Superior. However, there was a study back in 2021 through the DNR showing that lake levels in the Central Sands region, i.e. groundwater levels, are being affected by collective withdrawals of high capacity wells, mainly used for agriculture irrigation purposes. So there is some concern that overpumping can lead to decreased groundwater levels. A little bit more about capacity is that there are 575 municipal water utilities that are regulated through the PSC, and they're all required to file these annual reports. And based on these annual reports back in 2022, a little bit over 17% of the utilities that produce water was reported as non-revenue water. Of that 17%, it's estimated that, 13% of that total rather is due to water leakage, whether it's background leakage, which is kind of undetectable and it's always there, it's persistent, or actual water main breaks, one of the two. This does result in potentially, wasting water. Obviously, it's wasted water, but the order of magnitude of cost, although difficult to quantify, it could be in the tens of millions of dollars by the time you account for pumping costs, treatment costs, electricity costs, all that, which does result in inflated water rates for consumers. A little bit more here on drinking water condition. There's almost 23,000 rather miles of water main in Wisconsin, with almost 40% of it being older than 50 years. And a vast majority of the cast iron main that was installed before the 1970s soon, or probably already has, reached the end of its useful life, and it will require either replacement or rehabilitation. These help reduce water loss and operation and maintenance costs associated with repairing breaks. However, when you look at the numbers available from PSC, it's only about an average replacement rate of 0.5% a year. So you do the math, it takes about 200 years to, replace all the main. If you start now wanting to do 0.5% per year, that's more than double the expected life expectancy or useful life of typical ductile iron mains, which is about 80 to 100 years. Over the past 4 years, the average number of water main breaks in Wisconsin was nearly 3,300 breaks per year, about 15 breaks per 100 miles, which actually matches it's moving without me, which matches the American Waterworks Association's partnership for safe waters optimization goal for water main breaks. So at least we're matching that. Locating, repairing these breaks, it's expensive from both a financial and labor perspective. It can also often tie up the municipal labors for the better part of a day, cause traffic and business disruption, damage to private property, public property included as well. So it's a key to keep the breaks down to a minimum here. It's unneeded costs, unneeded labor. So here more about operation and maintenance. Wisconsin is one of the only few states where all municipal water rates, also known as tariffs, and the service standards are established through a state agency, in this case, which is the Public Service Commission of Wisconsin. So if they want to voluntarily raise their rates, review and approval through the PSCW is required. It's a 6 to 8 month process typically. But because of that arrangement, most water utilities here in Wisconsin are in a relatively good position to remain financially viable. However, ongoing committed capital improvement funding for water utilities is still lacking, evidenced by that 200-year, replacement cycle. And with limited government resources to go around, prioritizing spending on buried infrastructure is far more complicated than just replacing the water main when you do a road replacement project anymore. So because of that, it's a recommendation the water utility should be conducting a risk-based infrastructure assessment or an asset management plan to prioritize these projects to go into its capital improvements plan. They should also be evaluating the best options for incorporating the cost of ongoing long-term replacement into their rate structures. So several communities of these, they've integrated a long-term water main replacement cost into their water rates or tariffs using an expense depreciation method to basically cash fund their annual water main replacements. it allows utilities to pay for water main replacement pretty much through the year, immediately in that year without bonding or borrowing costs, thereby, reducing the overall total cost by avoiding interest on debt. So many utilities do take advantage of the DNR's Safe Drinking Water Loan Program, or the ASCE-WI. It combines state funds and capitalization grants from the US EPA and the Drinking Water State Revolving Fund. That's the national pot of money. So they offer fixed rate, subsidized, or low interest loans and grants, which they define as principal forgiveness. So back in 2021, the Infrastructure Investment Jobs Act, or bipartisan infrastructure law, was committed to providing more than $600 million in additional funding through the Safe Drinking Water Loan for 5 years, which is the federal fiscal years 2023 through 2026. And they do include separate funding categories for adding to just the base program, but also having separate buckets for emerging contaminants, which DNR here has mainly categorized or defined as PFAS, and then as well as lead service line replacements. So typically there have been more loan funds available than requested, at least in the past 10 years or more. I've been tracking this, but recently here, including this year, funding requests have exceeded loan dollars, which also mirrors the demand we've seen on the Clean Water Fund program side of things. So the program's popular, and whether or not it's because people are trying to glom onto this thing because they only know a year or two is left, or projects are, more projects come to fruition due to just declining and increasing in age or something like that. I guess that's remained to be seen. So in terms of public safety, back in 2022, more than 99% of Wisconsin public water systems, they met all of the maximum contaminant level, or MCL based standards that are set forth by the US EPA and regulated through the Safe Drinking Water Act. There was only 90 systems that experienced one of those MCL violations. And the most common contaminants that were found were bacteria, nitrites, arsenic, radium, and copper. According to a 2022 legislative report from the state's Groundwater Coordinating Council, that nitrate continues to be the most widespread contaminant, and it is increasing in severity and extent. 10% of private wells exceeded an MCL of 10 parts per billion, or per million rather, sorry. But one of the more significant issues, and I'm sure we hear more about this later here today, is the presence of lead in drinking water, which has mostly caused by lead service lines. It can have severe effects on human health, impaired brain development in infants and children, damage to nervous system and kidneys in adults. In 2022, there were 24 public water systems out of the 575 there that exceeded that lead action level of 15 parts per billion. Also, as a segue from that, in 2024, the US EPA finalized its lead and copper rule improvements. It lowers the action level from 15 parts per billion to 10 parts per billion. Also includes a proactive full LSL replacement period within 10 years, and that'll start in 2027. So although the total bill funding through the nation received $15 billion for LSL replacements, it does not cover the full expected cost of $50 to $80 billion, again, nationwide. So it's gonna hinder progress. To effectively remove this lead from water system, they'll need proper levels of funding, particularly for the customer private side, owned portion of LSL. Also in 2024, US EPA released its final and first ever national legally enforceable drinking water standard, again, kind of defined as the MCLs for 6 different types of PFAS. These are a group of human made chemicals used for decades in numerous products. We're talking nonstick cookware, fast food wrappers, stain resistant sprays, firefighting foam. I think almost every state has some sort of issue with this, and Wisconsin's especially one of those. Some of those adverse health effects include thyroid disease, low birth weights, and cancer. Some information about drinking water resilience innovation. the integrity of a water system and the safety of consumers drinking water can be threatened through a myriad of factors. So we got to make sure that there's proper planning in place so utilities can meet these future demands. The US EPA recognized this, and back in 2018, they signed or passed the America's Water Infrastructure Act, or AWIA, and requiring all water systems with more than 3,300 people to develop or update a risk and resiliency plan and an emergency response plan. And then every 5 years, they have to update it. And so the first of those updates are going to be due this year, which will be for communities serving more than 50,000 people. As part of PSC annual reports that are required every year, they're required to submit information regarding non-revenue water, as we kind of mentioned before, and that's defined through the American Water Works. Although they're not required to complete a full audit, that level of audit could provide a useful tool to help identify cost-effective intervention measures for reducing water loss, optimizing revenue capture. They should adopt some best practices as identified in the M36 water audits loss control program, and also potentially go through, there's a free audit it's a spreadsheet for the free water audit software. They could also hire leak detection services to kind of locate water main breaks as opposed to waiting for something to bubble up through the road or something like that. And as previously indicated, risk-based infrastructure planning might be another example of innovation in asset management. We could also look at implementation of advanced metering infrastructure, AMI. I'm sure people have heard about that. Another example of innovation to lower labor costs, reduce overall water usage, optimize revenue capture again. Then lastly, utilities should also perform a cost-benefit analysis on critical water mains to determine if there's some sort of innovative pipe rehabilitation procedure that could be used as a reasonable, cost-effective alternative to doing a complete main replacement. We're talking cured in place pipe, spray in place pipe, slip lining. There's all sorts of ones that could be used on the water side. So, yeah. So, what are some of the recommendations that we came up with to raise the grade? I'll just read these straight off here. Is to encourage, incentivize, or require water utilities to develop risk-based pipeline prioritization and asset management programs to assist in proactive water main replacement and reduce excessive water loss. Ensure that water rates cover the full cost of service, including operation and maintenance and long-term replacement needs. We recommend that utilities evaluate cash funding. Annual water main replacements using an expense depreciation mechanism, which is allowed through the PSC. We should recommend that they expand or strengthen the Safe Drinking Water Loan Program, increase principal forgiveness funding and opportunities, then streamline or reduce federal requirements to encourage participation. And the last three would be to increase and expand federal or state funding for replacement of LSLs or lead service lines to reduce ratepayer burden, encourage utilities to investigate water conservation and efficiency measures, including implementing uniform or increasing block rates and performing full water audits, and finally adopt innovative technologies to improve maintenance, reduce water loss, enhance productivity, and reduce life cycle costs. If you don't know where it is, that's where you can visit. You can just search for Wisconsin report card, and you can find the Google search will take you there. And thank you very much.
Thank you very much, Justin Bilskemper, for your report on Wisconsin's drinking water infrastructure. Let me remind our audience to please add your questions to the chat for Q&A at the end of the presentations. Next, we have Deanna Branch, who is the mother of Aiden and co-author with him of a book about lead poisoning for children. She's been deeply involved in advocacy to remove the lead pipe infrastructure that contributes to lead in drinking water. Take it away, Deanna.
Thank you. Good afternoon, everyone. My name is Deanna Branch, and I'll be talking about my advocacy journey in my wonderful church home and how I became an advocate for lead safety. Next slide, please. What is lead? Lead is a natural metal from the Earth's crust. Lead-based pipes, paint, and dust can cause a buildup of lead in the body over months and years. Young children are especially at risk. Symptoms include developmental delays and abdominal pain, neurological changes, and irritability. At very high levels, it can be fatal. State law says that a child is not lead poisoned unless the lead blood level is higher than 5 micrograms per deciliter. But there is no safe level of lead in the blood for a child, and every child reacts and responds differently to lead exposure. And the irreparable damage causes an onset of other problems for the child. Treatment always involves avoiding further lead exposure and lead-based products. It may include medication to remove lead from the body. Lead is a personal subject for me because my family was directly impacted. My youngest son, Aiden, was hospitalized twice due to severe lead poisoning. Aiden's first pediatrician did not address my concerns about Aiden's erratic behavior. It was not until a routine lead check at the local WIC office that I became aware of Aiden's high lead level. By the time Aiden was lead tested by another pediatrician, he was already being admitted into Children's Hospital. His lead level was at 40 micrograms per deciliter, and he had to take succimer medication to remove the lead from his body. Further lead exposure in the home caused Aiden's lead level to skyrocket to 50 micrograms per deciliter, resulting in Aiden being hospitalized yet again. The health department got involved and conducted a lead report on the house, finding all of the 3 main sources of lead in the house: the water, paint, and the soil. After receiving no help or support from the landlord or rental agency, Child Protective Services got involved and informed me that Aiden could not be discharged from the hospital because I could not provide a safe place for him to live. I ended up losing my job and breaking my lease and moving into a homeless shelter. I turned my anger at the injustice I face into advocacy. This is my church, Help the Lutheran. They had the first lead summit was done in my church, and I testified about my family's journey along with another parent, Saida Henson, at that lead summit. I also talked to the health commissioner, the mayor, common council, and I advocated for the Berkeley Mons pilot project. $240,000 of the city's funds at the city budget meeting would provide lead education kits, which include a certified filtering pitcher to new mothers immediately before they leave the hospital after giving birth. The Berkeley Mons pilot project was approved into the Milwaukee 2020 city budget. Next slide, please. In 2022, with the help of Help the Lutheran Church and the Welcome Church and the USC Homeless Justice Network, I was able to publish a children's book detailing Aiden's experience with the lead monster. The book is completely illustrated by Aiden, detailing his experience with the 3 lead monsters of the water, paint, and soil. My goal for the book is to spread lead awareness, teach children about lead from a child's perspective, and educate families on how to stay lead safe. I make sure I bring free copies to every event that I'm invited to make sure that parents have access to that book. Next slide, please. The lead safe kits, Milwaukee Health Department provides lead safe kits to families affected by lead exposure. Lead safe kits include a faucet filter, a water pitcher, and refill filters, Swiffer dust mops, bleach wipes, and duct tape, and a pamphlet with helpful tips about how to stay lead safe and what foods help with lead absorption. They are provided free of charge. We hand them out at our church, Help the Lutheran Church, the corner of 18th and Locust, at Strong Baby Sanctuary events, any cold events, applicable cold events. And we always educate the parents about lead and what foods can help absorb the lead, remove the lead from the body for children. Next slide, please. Since 2023, at the first Accelerated Lead Pipe Replacement Summit at the White House, I have been advocating with the Environmental Protection Agency to remove all of the lead pipes out of the city of Milwaukee. The original plan would have taken 40 years for all the lead pipes to be removed from the United States. I advocated for funding towards the Accelerated Lead Pipe Replacement Program. And in 2024, the EPA reduced the deadline to a decade or less for all the lead pipes to be removed from the United States. And that's my family, my son at the last summit when I introduced the vice president. Next slide, please. Thanks to the funds coming into the city of Milwaukee, the Milwaukee Workforce Development Commission was able to provide free training to Milwaukee residents on how to replace lead pipes. On June 2nd, 2010, Rashawn Spivey founded Hero Plumbing, LLC in Milwaukee, Wisconsin. In addition to his master plumbing status, he boasts a compelling resume, including over 30 years of replacing lead pipes. Thanks again for the funds coming into the city of Milwaukee. Hero Plumbing, a small Black-owned business, was able to grow vastly in size, hiring more Milwaukee residents and buying more resources needed to replace the lead pipes out of the city of Milwaukee. They started out removing over 100 lead pipes out of homes and daycares in Milwaukee. Now they are removing over 1,000 lead pipes a month out of the city of Milwaukee. Hero Plumbing is the main source of the lead pipes being removed out of the city of Milwaukee. Next slide, please. The bipartisan infrastructure law provided the necessary funding to remove all the lead pipes from the United States, and that is why Rashawn Spivey and I have been advocating to keep funding the work being done, meeting with President Biden and Vice President Harris every time they came to Milwaukee in support of the bipartisan infrastructure law, even filming the political commercials in support of the funding receiving from the bipartisan infrastructure law and getting the chance to speak about our advocacy work at the Democratic National Convention. Next slide, please.
Deanna, your time is almost up.
Okay. This is the Mental Health Equity Task Force I'm a part of to restore health services in the community. The clinic that saved Aiden's life was closed down, and I have been advocating to get it reopened, and it will be reopened within the next year because of my advocacy work. Next slide, please. And this is my church and all the resources and programs that we provide for the community. I won't go into detail because I'm almost out of time. So next slide, please. And this is some of my advocacy work, and my sons are advocates too. Aiden's lead level is down to 6.5, and my daughter was born lead free because of all of my advocacy work and training. And that's why I like to teach and tell parents that I meet. Next slide, please. That's Aiden and my lead free daughter. Next slide, please. And that's my contact information in the website for more details, information about who I am, who my church is, and what we do for the community. Thank you all so much for your time.
Thank you so much, Deanna, for your remarks. Again, let me remind the audience to add your questions to the chat. I'm sure that Deanna's presentation stimulated many questions. Next, we will hear from professional engineer Jen Hurlebaus, who is the capital planning engineer for the Madison Metropolitan Sewerage District. She was the lead author on the ASCE report card section on Wisconsin's wastewater infrastructure in both 2020 and 2024. Welcome, Jen. Please take it away.
Thank you. All right. As I am Jen Hurlebaus, and I was lead chapter author for the wastewater section, and as Anne mentioned, I work at the Madison Metropolitan Sewerage District. I have been here over 8 years with 17 years in consulting prior to that. So most of my experience has been on the collection system side, but obviously getting a little bit more involved on the treatment plant side as well. So for the wastewater chapter, 2024, the grade went down from a C- in 2020 to a D+. kind of the opposite of what Justin had mentioned as far as drinking water. And for wastewater, a lot of that was due to the fact that for the first time, the Clean Water Fund program was unable to fund every project application in 2024. So now funding has become a concern for wastewater, which is a big part of why that grade did decrease. So just kind of a definition of what a grade of in the D range means is that infrastructure is in poor to fair condition, mostly below standard, with many elements approaching the end of their service life. A large portion of the system exhibits significant deterioration. Condition and capacity are of serious concern with a strong risk of failure. So in Wisconsin, there are 603 operational municipal wastewater treatment facilities and 867 operational wastewater collection systems serving 4.36 million people. Our state's population is estimated at almost 6 million people, which means approximately 27% of Wisconsin residents do not have access to wastewater collection and treatment, but mainly rely on on-site systems or septic holding tanks. But what we're talking about more is the wastewater infrastructure, here in this schematic. So we do break down into those two categories, collection systems and treatment plants. Collection system infrastructure includes the pipes to carry the wastewater from the property to the wastewater treatment plant. Often pumping stations are needed to pump the water in low areas where it's not possible for wastewater to flow to the treatment plant via gravity. At the wastewater treatment plant, processes reduce the pollutants to meet discharge requirements and return clean water to the environment. The schematic shows a residential home, but wastewater is also generated from businesses and industrial facilities. And I think it's worth noting that there are several owners of wastewater infrastructure. So let's dig into this figure a little bit more. So it starts at the property owner is responsible for that private sewer lateral from the building to the connection to the municipal sewer pipe. For many communities, that ownership does not end at the property line and often extends out to the pipe that is under the street, maybe in the middle of the street. Municipalities have sewer pipes then to collect the wastewater from the individual property laterals. Municipalities will either have their own wastewater treatment plant, or they may send their flow through a regional sewer system to a regional treatment plant, like where I work. For example, I work for a regional wastewater utility that serves 24 municipal sanitary districts. So now that we have defined a little bit about wastewater infrastructure, let's dig into some of the report card categories. So for capacity and condition, at our utility, we evaluate our system for capacity and condition needs, and we plan projects. We fill out a compliance maintenance annual report, or a CMAR, each year to send to Wisconsin DNR that reports on meeting discharge requirements for treatment and if overflows occurred. However, that data is not in a centralized database system for statewide analysis reporting. The only available data provided for the ASCE report card was a spreadsheet of wastewater overflows. So more capacity in the system is needed as communities grow, but growing communities are usually not the reason for overflows. It's not difficult to find sanitary sewer collection systems that are beyond their expected design life and in need of replacement or rehabilitation. So the older systems are susceptible to inflow and infiltration, such as rain and or groundwater that seeps into the system and overwhelms pipe and treatment plant capacity, causing backups, sanitary sewer overflows, and wastewater bypasses at treatment plants. However, rainfall isn't the only reason why overflows would occur or could occur. Equipment failures, power outages, broken pipes are just a few of the other reasons attributed to reported overflows. As this chart shows, from 2019 through 2022, there were a total of 790 reported events that totaled almost 4 billion gallons of municipal wastewater overflows. Industrial wastewater overflows, data was not available to be quantified for this report. Combined sewer systems or collection systems that collect stormwater and wastewater accounted for 90% of the total overflow volume just from 7 reported events over that 4-year period. So a separate sanitary sewer systems, they had more overflow events, but significantly less volume. And additionally, overflows occurring at treatment facilities were reported, but were the lowest portion of the total volume. So just a couple of suggestions for raising the grade as far as condition and capacity concerns is that, definitely there is a need for capital improvement projects to achieve these needs. Potential impacts of climate change, such as I&I, may impact collection systems such that future capacity will be more difficult to predict and costly to address. So ongoing monitoring and planning are required to maintain or achieve those systems. Causes of overflows included rainfall, equipment failures, broken pipes, and power outages. So a consideration and recommendation is to think about adding on-site power generation at lift stations to match the requirements that are on treatment plants. And Justin mentioned this several times too. It was also a recommendation for wastewater, is that robust asset management programs are needed for capital improvement planning. So operation and maintenance, big category. So these pictures are just a few examples of the vast array of wastewater infrastructure to operate and maintain. From swapping out open pick hole manhole covers to reduce inflow and infiltration, to unplugging a pump or building electrical control panels at a pump station. Your operations and maintenance is your core work that's done every day to convey and treat wastewater. Wisconsin Administrative Code NR 210 required that all owners of collection systems develop and implement a capacity management, operation, and maintenance, or CMOM, program by August in 2016. As mentioned earlier, municipal wastewater treatment plant owners are required to submit a CMAR report every year to DNR. And that CMAR is that self-evaluation tool that describes your management activities, some physical conditions of the system, and performance of the treatment, and which can impact permit compliance. So there's some other sections, including staffing, preventative maintenance, operations certification, education, financial management of the systems. So the facilities report on whether they have O&M manuals, and then rate the overall maintenance of the plant. They also report on a whole effluent toxicity, or WET, failures in the CMAR. And the primary goal of WET testing is to ensure that wastewater effluent discharged into Wisconsin surface waters do not negatively impact aquatic ecosystems. In the last 5 years, the state of Wisconsin has seen an increase in WET test failures at wastewater treatment plants. Failures are caused by a variety of reasons, including overdosing of phosphorus treatment chemicals and industrial charges to municipal systems. So as wastewater facilities work on decreasing toxicity in their wastewater effluent, more work is needed to evaluate the public health concerns of toxicity. There is also only currently one laboratory in the state of Wisconsin that is certified to perform these WET tests. This causes capacity problems for facilities trying to get their WET tests performed during the required time periods. It's also an additional large expense for these facilities to ship the many samples required for this test to reach the lab in Superior, Wisconsin within the 24-hour holding period. So the recommendations for raising the grade related to operation and maintenance, we recommended that to convert the CMAR data collection into a database format where data can be queried and quantified for improved statewide reporting and data analysis. We need more certified laboratories in Wisconsin to perform these WET tests. And treatment facilities should complete vulnerability assessments to help identify and prioritize the best security measures for each wastewater system. And one kind of new thing, I think, is cybersecurity. So for funding and future need, So in 2022, EPA Clean Water Needs Survey estimated that municipal wastewater needs for Wisconsin totaled 5.5 billion over the next 20 years. The Wisconsin DNR and the Department of Administration jointly administer the State of Wisconsin Clean Water Fund program under the Environmental Improvements Fund. The program has provided over 6.9 billion in loans since it began in 1991. In Wisconsin, the state match is provided through revenue obligation bonds. Since the beginning of the Clean Water Fund program, through the 23 state funding cycle, no application had been denied due to a lack of loan funds. However, last February, stakeholders were notified that applications for financial assistance in the 24 fiscal year significantly exceeded available funding. The funding list for 25 was released in December, showing a continued high demand for financial assistance. Requested project funding in 25 totaled $524 million, exceeding the 400 million allocated for the program. Utilities are having to seek other funding sources, such as general obligation bonding, but this will cost ratepayers more due to a higher interest rate. It's likely projects are being delayed due to the uncertainty in funding. This is concerning because the backlog of projects is only continuing to grow. More federal, state, and local funding is needed to help municipalities and utilities make upgrades to maintain their systems and meet existing and new regulatory requirements. Specifically, permit holders will incur significant capital and operating expenses to deal with PFAS once limits are established. Planning is necessary for the physical facilities and financial needs for achieving these anticipated limits. So the grade of a D+ for Wisconsin wastewater infrastructure is not a report card on the hardworking people working at utilities, municipalities, or DNR. The grade reflects the risk of aging infrastructure, needs to meet new regulatory limits, and the uncertainty in funding to complete needed capital projects. Wastewater infrastructure needs funding, but people are needed to operate and maintain wastewater infrastructure every day. We need to develop and grow the wastewater workforce to meet current needs and address future challenges. We need operators, mechanics, electricians, engineers, chemists, and construction workers, just to name a few. And as we often say at my work, it takes a special kind of person to want to work at a wastewater treatment plant. I am privileged to work with such a passionate group of people, but while we are passionate, we haven't done a great job of advocating for ourselves or educating the public on wastewater infrastructure. That is changing. Wastewater utilities are doing more social media and public outreach to help people understand the value of water and wastewater infrastructure and what it takes to provide those services every day. Thank you.
Thank you so very much. Jennifer Hurlebaus, for the informative report on Wisconsin's wastewater infrastructure. After our next speaker, we will have a Q&A session where you, the audience, can ask questions of all of our panelists via Anastasia and via the chat. So please remember to add your questions to the chat. Our final speaker will be Kevin Schafer, Executive Director of the Milwaukee Metropolitan Sewerage District. Welcome, Kevin. Please take it away.
Good afternoon, everyone. Let me pull up my slides here. There we go. Hi, everyone. Kevin Schafer, Executive Director, Milwaukee Metropolitan Sewerage District. I'm a civil engineer. I started at the district in 1998 as the head of the engineering department, and I've been executive director since 2002. So been doing this for 22, 26 years, however you want to do your math. And we're really trying to take a holistic approach to what we are trying to do, which I'll explain here. Some of the points that were brought up earlier about the funding at the state level is a huge issue, and we are going to be working this coming budget cycle trying to get additional funding from the legislature, the state legislature, to fund clean water and drinking water initiatives. Just a quick slide on what Milwaukee Metropolitan Sewage District is and does. We are a wastewater treatment facility, not drinking water, but just wastewater. We have 2 water reclamation facilities, and we also provide flood management. On the previous presentation, you heard about combined sewers and separate sewers. This hatched area on this map is a combined sewer area, and the rest of the area is a separate sewer system. So we're a regional utility that receives flow from 29 different municipalities, as you see on this slide. And so we have to take the flow that comes to us and then try to treat that and discharge it back to the environment in a clean fashion. In 2009, after going through many years of battles on this, I decided to write a vision for the year 2035, where I set a goal for zero combined and sanitary sewer overflows, zero homes in the 100-year floodplain, trying to restore some of the green features of this very urban network to try to have nature help us manage water better. We also, that's the left side of my brain. The right side of my brain is the climate adaptation mitigation initiatives, where we want to be 100% renewable energy sources for our uses, with 80% of that being self-produced. And you can see some of the other goals here, but I'm a firm believer that climate is changing. I'm a firm believer we're already seeing it, and that we need to take steps now to try to address the future. And for us to take this approach to look at bringing nature back into the equation and to try to manage overflows, reduce overflows, we've taken what I like to call the watershed scale approach. We're looking at the entire Milwaukee River watershed, because water flows downhill. It's a very basic understanding. Water flows downhill. So how do we manage that water so that it does not overload the system as it flows downhill? As I said, we have 2 water reclamation facilities, which I'll talk about in a minute. We have a flood management authority, which I'll show. Green infrastructure, this is trying to manage every drop of water where it falls so that you are reducing that runoff downstream and reducing the pollutant load downstream as well. And then up in the, throughout the entire watershed, and a lot of it in the more rural areas, we're working with programs that we have that we call green seams, where we're purchasing easements, working soils, and then we just recently started a reforestation and wetland restoration project. I'll go into more detail on all of these projects as we go forward. And finally, the EPA's area of concern, I'll talk about that also. It's a massive cleanup of some of the polluted sediments in this, in the bottom of the estuary in this very industrial setting. So here's the 2 different water reclamation facilities that we have. Jones Island on the left is right downtown Milwaukee, and then South Shore is in Oak Creek. On a normal day, these treatment plants are treating around 55 to 60 million gallons a day each. So we treat around 130 or so million gallons of wastewater every day. When it rains, those 2 treatment plants can total up to 600 million gallons a day. So we really see a spike in the amount of water that comes to us through rainfall events, which Jennifer talked about earlier. And it's the normal treatment process. It's preliminary, primary, secondary, and disinfection. And we discharge back into Lake Michigan, which is our drinking water source. Just a quick plug. When you treat wastewater, you have cleaner water that you put back in the environment, but you also have biosolids. And biosolids are basically the microorganisms of bodies that are used to treat wastewater. So since 1926, MMSD has been producing a product called Milorganite, Milwaukee Organic Nitrogen, which you can probably find in a True Value, Ace Hardware, Menards store near you. And so it's heat treated. We use it, this method, to dispose of our biosolids, and we sell roughly $11 million a year of this product throughout the country. It's a great fertilizer for your lawn. We also have a deep tunnel system, which is our key element to trying to reduce combined sewer and separate sewer overflows. We have 526 million gallons of storage, about 300 feet underground. This is just really a large bathtub. When the rains hit, heavy water use of the system comes into play. That water spills into the tunnel down 300 feet, flows through the tunnel to our Jones Island plant, where we have 3 70 million gallon day pumps that pump that water up, treat that water, and discharge it into Lake Michigan. And these are some pictures of some of the construction photos of that. Since the deep tunnel came online in 1994, we've captured and cleaned 98.6% of all the water that's come to us. So that CSO number that you saw earlier, for us, that would be that 1.4%. We're required by the federal government to be greater than 85%. And as you can see, we're much higher than that. So the federal and state government, in a lot of cases, is using Milwaukee as an example for how to manage combined sewer and separate sewer overflows throughout the country. We also do flood management, and we don't do flood management like a lot of places. When I started at the district in 1998, almost all of the rivers in the area were concrete lined, and that has its own issues, but it really cuts off the water from nature. So we have a massive flood management program where we are removing concrete lining. We're providing 100-year protection for flooding, against flooding in the waterways. And this upper middle picture is Lincoln Creek project. Upper right is Underwood Creek. The bottom right is the Kinnickinnick River flowing through Pulaski Park. If you've not been to Pulaski Park in Milwaukee in a while, it's beautiful today. You should go see that. And the bottom left is the County Grounds Project, which is a large flood management storage facility. That's the largest facility in the state. I mentioned green infrastructure. We started this in 2002. This was the year I started as executive director. And we have over 150 million gallons of storage from green infrastructure. This is rain barrels, rain gardens, green roofs, bioswales, porous pavement installed throughout the area. And what this does is when the rainfall hits it, it holds that water, or it allows that water to infiltrate into the groundwater. And this is a great way to mimic nature to allow us to manage those flows downstream better. And as you can see, it's a great workforce development effort and a great way to get the public involved with what we do. Here's some other examples of that. Upper left is Cudahy City Hall. That's their parking lot, porous pavement. You'll see if you drive around the Milwaukee area, a lot of bioswales that MMSD is paying the municipalities to install, managing that polluted runoff that's coming off the roads and holding it and then allowing nature to treat it. The right picture is the Schlitz brewery area that has been redeveloped. This is one of our earliest bioswales that we built. And the bottom left is the underpass for Marquette Interchange. And this used to be just a impervious area that was not used for anything. It's actually across from DNR's new headquarters in the Southeast region. And so we went in and worked with the DOT and the city of Milwaukee, and those pipes that you see where the water is coming off the interstate, we're capturing that water now, putting it through a biofilter system under the freeway so that we can remove pollutants, reduce quantity that's flowing downstream, and protect our rivers in Lake Michigan. Green seams I mentioned before, this is a program where we're purchasing easements on property to absorb land. We're not allowing any impervious cover, so no concrete, no asphalt is allowed on these surfaces. We've got about 3.1 billion gallons of ability to store water in this land, and it's around 5,500 acres preserved. We're also working with farmers, mostly in the upper Milwaukee River watershed, trying to address the runoff from farmland, which sometimes has heavy phosphorus, nitrogen loads, sediment loads. We've got about 1,700 acres preserved, around 840 million gallons stored. It's in partnership with the federal government, and just this last October, we received a $19.8 million grant from USDA to continue this program. So again, we're being looked at as one of the leaders in the country for how to manage water on a watershed scale. We also started a wetland restoration and reforestation program. We are just implementing this in the last couple of years. We are planning to plant 6 million trees in the greater Milwaukee watershed, whether it's rural, urban, suburban. And we want to restore 4,000 acres of wetlands because those are really the watershed's lungs. They are the way to store and treat water naturally. And just getting the community involved, as you can see in this picture, is just a huge benefit. And great partnerships along the bottom. All of these folks have been really good to work with. I mentioned the area of concern before. I think there's something like 43 areas of concern around the Great Lakes. Milwaukee is one of them. The Milwaukee Estuary is one of them. In 2019, MMSD volunteered to build a very large storage facility, which we call the Dredge Material Management Facility. That is this upper right picture that you see. that is under construction today. It will be completed in 2026, early 2026. And once that is completed, the EPA will come and they will dredge contaminated sediments that have been sitting at the bottom of our estuary for 100 years. They will dredge those, put them in this containment facility, and store those safely going forward. As John Gerda, one of our local historians, said, we're fixing the sins of our fathers. Lower right was Estabrook Dam. We removed that because it was not functioning and it was a impediment to habitat fish migration. Upper left is the Clutch Dam Fish Passage. That was just completed a year ago. And we built a fish passage around Clutch Dam in Glendale to allow better fish migration upstream. And the bottom left picture is the Burnham Canal project. We've gone through phase 1 of that, where we've basically sealed pollutants in the bottom of that canal. We'll come back in a year or so to build a wetland on top of that. And in this very urban setting, we will soon have a linear green wetland to supplement the development in that area. And of course, on the day-to-day cycle, we are out removing trash. We have our own boat that is a river skimmer that we named the Leonard Skimmer after the band. And it's been great. It goes out probably from April through September, collecting trees, debris, whatever is floating in the river. We partner with the city of Milwaukee, the Port of Milwaukee. They take that trash and dispose of it. And it's just a great way for folks to see that we're trying to be good stewards of the waterway. And it keeps a lot of pollution out of Lake Michigan.
So Kevin, I just want to remind you, you have about 2 minutes left.
I've only got 2 slides, so we're good. Wastewater plants really are resource recovery plants. We can recover clean water, which we're doing already. We can recover nutrients, which we're doing with Milorganite. We can maybe recover meds that might be floating, which are floating through the wastewater. So this is a way to really try to use these as energy producers, as ways to be more sustainable moving forward. And we're working on doing that with both of our water reclamation facilities. And here's pictures showing that. So approximately 27% of our energy is coming from renewables at this point. As you saw in the goal, it was to be 100% with 80% self-produced. Annual savings estimated right now is around $1.6 million, and our greenhouse gas reductions since 2005 is 18%. So the upper right is solar panels on top of our dryer and dewatering building at Jones Island. Bottom right is biogas storage facilities where we collect biogas off of our treatment process and use that to power the South Shore Water Reclamation Facility. And the bottom left is a landfill gas turbine project that has been operational since 2014, where we are capturing landfill gas, piping it down to the Jones Island plant, cleaning that gas and using that instead of coal or natural gas to power our systems. So we are slowly, but step by step, working towards that 100% goal of renewable energy. We've also found that we need to really support this with a strong research program. So earlier in 2024, we announced that we're going to build a research facility at our South Shore plant that will have direct connections to the water systems at the plant. So we can do live, real-time testing of wastewater as we move forward. And with that, none of this can be done on our own. We really need partners to help. And we're out there collaborating, doing social media, really trying to bring everyone into the discussion about cleaner water. And thank you for having me.
Thank you very much, Kevin Schafer, for that informative presentation, and congratulations on an excellent record of success through innovation. Audience, please continue to add your questions to the chat for any of our 4 excellent speakers, Justin Bilskemper and Deanna Branch, discussing Wisconsin's drinking water infrastructure, and Jen Hurlebaus and Kevin Schafer reporting on Wisconsin's wastewater infrastructure. Now back to Anastasia for the Q&A.
All right, I am going to get all of our speakers together on the screen for everyone, if they can turn on their cameras. But while I'm doing that, we can start out. We got a lot of questions about PFAS, and Justin, since I've got you on there. I'm going to start with you. What should individuals do if PFAS is in their water or in their well?
And maybe I misread the question. Maybe they're asking how do they get it tested, or maybe that we're past that point is, what happens once they find it, right? I'll answer the first one because I thought it was a question that there's no funding or mechanism to get it tested. You just have to go through a certified lab, to my knowledge. There's PFAS websites here. There's a PFAS contamination in private well website on the DNR page as well. They just said there's no funding available, but they recommend private well owners who choose to sample the well doing a certified lab. In terms of what happens if you find it, I don't have an answer right now, actually, without doing some research. There may be some source, short of buying bottled water, I guess, and using it in the interim. I don't know if there's a in-home or a point of use like filter you could use like you use for a myriad of other contaminants in drinking water. So I'm afraid I don't have an answer for you.
Absolutely understandable for an emerging contaminant. Thank you. And not to, advertise for the league in this moment, but we did have a couple of programs related to PFAS in Wisconsin waters in 2024 that are on our YouTube page that can give some more information as well. In terms of PFAS in wastewater, Jen and Kevin, would you be able to speak to how wastewater is being tested for PFAS, the techniques that are being used when PFAS is found, things like that? And I'm so sorry, 1 second. Deanna, could I ask you to start your video so that I can pin you with everyone else so everyone can see when you're talking? And now that I interrupted myself, please, Jen and Kevin.
Okay. I didn't know if Jen wanted to go first or not, but I will.
Go ahead.
So we're fortunate in the Milwaukee area that we do test for PFAS. We have, as I said, we produce Milorganite. We sell it throughout the country. The only state that we do not sell it in is Maine because they've banned all biosolid fertilizers. But we sell it throughout the country. Michigan has some very good limits that they've placed on land application of biosolids, and their number is something like 20. I don't remember the unit. And when we test our Milorganite product, we're in the 7 to 8 range. So we're way below any limit that's out there. And we are, as I said, very conscientious of any PFAS impacts on Milorganite. And we don't see it in our effluent as well. So DNR came in and they wanted us to monitor for, or to test for this several years back. And we've been doing that. And fortunately for us, we don't see a hotspot of source. But what we're finding is there's enough in our system because it's coming from all of your Teflon pans, all of the different clothes that you wear. So if you really want to try to stop PFAS, we need to stop using it. And you need to look for this as an item when you're buying product.
Yeah, I will concur with that. And I think PFAS are being banned in many countries for source reduction, but one of the biggest exporters, China, obviously of products, is not. So, something to be aware of. And I put in the in response to that question a link to a website page from Madison Metropolitan Sewerage District. We have been also testing for a couple of years now for our wastewater for PFAS and also are below the limits. But the website and the education efforts and outreach actually did win a national I'm NACWA. I never remember the full acronym for that, for the communication and outreach efforts for this. So it's a really good resource if you want to get a little bit more information on testing and monitoring and where PFAS and wastewater.
Perfect. Thank you, guys. In the same vein of, scary contaminants that we're hearing a lot about, someone had asked, what are the levels, if any, of microplastics in municipal wastewater? either incoming or effluent.
Hmm.
We do have them. Oh, I'm sorry. Go ahead.
Yeah, I think that they're there, obviously, but it's not something that, I think we're really, we're not required to do anything about at this time, and, it's, you know, I'm not aware of any real specific, you know, discharge limits or any sort of regulatory requirements regarding microplastics at this time.
Yeah, and we're fortunate here in Milwaukee. We've got the University of Wisconsin School of Freshwater Sciences. They do a lot of sampling and testing for that. So they're trying to develop some techniques to better monitor for it, and then if we can, try to remove it.
Perfect, thank you. We had someone in the chat asking about sort of the relationship between industrial wastewater and municipal and regional systems. Do the industrial entities have responsibilities towards the what they are discharging into the municipal systems? How does that work?
I think it depends on which municipality and which utility and what they have in place and how they do that. So I know, you know, we haven't been a heavy industrial area in the Madison area in the past. We don't really have a specific industrial program, but there are pretreatment. There are permits that can be issued, you know, if discharger meets certain requirements to do either separate monitoring or but you know, for us, it's, you don't have like each municipality then may do their own type of billing for that. And they may have a different tiered structure for industrial discharges. So, Kevin probably is the better one to answer this. They have a pretty robust industrial program at Milwaukee.
Yeah, we've had a industrial waste pretreatment program going since like 1975, way before I got here. And we have crews that go out and every so often, I don't know the time frame, but go out and monitor industries for their effluent that they're putting into our system. They have to meet certain standards that we give them a permit to operate under, because one bad slug of something from an industrial treatment could kill out the biology of our wastewater plants. So we want to protect our wastewater treatment abilities, and they do pay for that pretreatment program.
Thank you both. We had a number of questions. People are very curious about the Milwaukee wastewater system. Some questions about the product Milorganite. What are the steps that it takes from, you know, from being a wastewater biosolid to becoming that product on the shelf? Is it processed, tested by an outside entity? And also, is this something that a lot of wastewater systems do, or is Milwaukee kind of on the vanguard for that?
Oh boy, what a great set of questions. So Milorganite, Milwaukee organic nitrogen, we've been producing it since 1926. The process for producing that is the sludge that comes off the bottom of the secondary aeration system. We take that, we digest it so that we can remove some of the water from it and produce energy from it as well. And then we take those digested sludge volumes, we put them through a dewatering and drying system. We heat the biosolids up to 100 and something degrees, forgot what it was, that is certified by EPA as killing the pathogens that are in it. Then we pelletize this product, put it in a bag and sell it. We don't make money on Milorganite. It's really a cost offset approach, because we're going to produce Milorganite or biosolids no matter what. So you either incinerate it, you try to land apply it, you want to do something with it. This is a way for us to have a revenue stream, as I said earlier, around $11 million a year. And there are other utilities around the country, either just starting it or having gone for a while. I know Louisville, Kentucky, Houston, Texas, maybe New York.
Interesting, perfect, thank you. Someone had asked if there's any practical way to decontaminate the material that is dredged out of the Milwaukee estuary.
So the EPA, along with many consultants, looked at this for at least 15 years, different ways to dredge the material and either treat it, utilize it, or take it to a safe spot. They ended up coming down to the solution, which is what we're implementing now, which is to build that storage facility. It could probably be treated, but the cost would just be so prohibitive. This material will stay in this facility. It'll sit there for 15 or 20 years until it totally compacts. And then it can either be a park on the lakefront or it could be an extension to the Port Authority.
Okay, so no fiscally practical way currently, understandable. On a more positive note, you had mentioned using natural elements to aid with the Milwaukee treatment system. Can you talk a little bit more about what that looks like?
Sure, that's the green infrastructure work that I tried to highlight in the PowerPoint. So we are, instead of just waiting for the water to come to us and then overload the system, we're trying to manage that drop of water where it hits the ground. We're trying to either allow it to infiltrate into the groundwater or to allow it to grow plants that will increase habitat. So we are building rain barrels, rain gardens, porous pavement, bioswales throughout the region. These systems, when the water hits it, they will help filter some of the pollutants out of that water as it moves downstream. It also will store it and maybe delay it during a heavy rainstorm so that it comes to our system later and not one time when it's being overloaded.
Perfect, thank you. I want to do one more question on wastewater before we shift over to some drinking water questions for a bit. And this might get to sort of the funding that our wastewater infrastructure needs us to advocate for. Are there plans to create a new analysis lab besides the one in Superior?
Good question. I don't know.
I don't know either.
Maybe the question should be, should there be plans to create a new analysis lab? Would you like us to tell our legislators that there should
Right.
be plans?
Well, yeah, so my co-author was Laura Gerald at DNR, and she was the one who had brought this wet test failures kind of issue it as a new changing thing that has occurred since we worked on the 2020 report card. You know, I think this really was a test that rarely failed, and it just really wasn't a concern. And so she had noticed this was happening more frequently, and when you have more of these tests, then, you know, because if you have a failure, then you have to do a retest. So your frequency of testing has just increased significantly in the last few years. And so, you know, one lab might have been fine until just recently, and so she was advocating that there is a potential concern there.
Good to know. Thank you. Shifting over to drinking water, we have a couple of questions around sort of the separation between more populous areas, less populous areas. Justin, is there a difference between large cities and smaller cities with regards to the estimated remaining like functional lifespan of the water pipes and other infrastructure?
I think it's mainly built around when said community was established. I'm sure a lot of the older cities and the bigger cities, I mean, we still got water main that was installed before 1900 in several communities that we know of. I'm sure Kevin's shaking his head, yes, Milwaukee, I know it's in Fond du Lac, I know it's, we removed wooden pipe up in Bayfield, you know, when we worked there, sort of thing. So, and Bayfield's like 400 people or less, and Milwaukee is massive, right? The biggest one in the state. So I think it just depends when they started. I think larger communities might have a little bit easier from a funding perspective, although that might not be entirely true. You know, small communities just have less resources to go around, and they need the same amount of stuff. You know, they still need water treatment, they still need a water supply, they still need wastewater treatment, regardless of how many people live there. So economy of scale sometimes works in larger communities' favors as well. and how, and what rate can they replace their water main, I guess. Did that answer your question, Jake, or not?
I think it answered it from my view. Absolutely, that makes sense. Then another question was asked. Would you say that safe drinking water loan requests are predominantly from rural or urban communities? And what is driving the increased fund requests?
I think I tried to address the increased fund request with, there's only a couple years left of the bill funding here. So everyone's trying to hop on the bandwagon before it goes away. So that's probably the one reason why we're seeing it being more popular here. In terms of rural versus urban, I think it comes down to how generous funding is as it applies to a community. So disadvantaged communities get more attractive interest rates. You know, they get 33% of market rate if they're a disadvantaged community as opposed to, I believe, 55%. There is more principal forgiveness associated with disadvantaged community criteria as well. So typically we've seen a lot more, I guess, smaller communities pursue safe drinking water loan funding, because again, that might be their only way to get that funding in the first place. Large communities, again, may have a better way to cash roll or fund projects without having to go to a regulatory agency for said funding.
Interesting. Okay.
I was
I'm
going to
sorry,
jump
did you
in.
want to jump in? Go ahead.
I was going to jump in on the clean water side. One thing that I've heard that happened was when the bipartisan infrastructure law was passed, it has a Buy American, Build American clause in it. And so equipment had to be built in America to receive some of these funds. And so that sped up all of the utilities around the country and in the state of Wisconsin to apply for these loans, because there was a cutoff date that if you met a certain milestone before that date, you didn't have to meet the Buy American, Build American requirement. That forced a lot of projects into the pipeline, and then there wasn't enough funding to pay for it.
Yeah, there was a May 15th, 2021 or 2022 deadline where if you started design before that point, you were allowed to fall under the existing AIS, American Infrastructure, or American Iron and Steel requirement, which is a permanent provision of Safe Drinking Water Loan and Clean Water Fund. But that waiver was sunset, I believe, at the end of last year or the previous year, or something like that. So no longer, if you started design prior to that previous May 15th point, you still now have to adhere to the Build America, Buy America requirements, which are very stringent. A lot of communities, a lot of consulting firms are kind of ripping their hair out trying to figure out how we're going to meet this 55%, final product must be BABA compliant, or that portion of the project or project which just might not get funded anymore. And especially on the electrical component side, I don't know, Kevin, if you're seeing the same thing where we're talking electrical upgrades or SCADA system, MCCs, we're having a lot of troubles finding manufacturers, suppliers who can meet these BABA requirements.
Yeah, it's the same on the wastewater side, yeah.
On a semi-related note in terms of funding, and this could be answered by any one of the four of you, do you think that a greater public awareness of especially water system contaminants, like the wonderful work that Deanna is doing, and on the public side, the wonderful work that you all are doing, trying to educate the public from within those systems, do you think that greater public awareness that's been growing is resulting in better funding or more pushes for better funding to help with these needs?
Well, I do still feel like, as far as, if the infrastructure, water and wastewater has kind of always been out of sight, out of mind, taken for granted. People don't really understand it. You don't see it, so it just doesn't get the attention that, say, roads, bridges, those more, easy to see. So, I see it from our municipalities of the types of projects that, there's just more public pressure, I think, on meeting, doing a street project maybe before you would spend money on your sanitary sewer infrastructure. So, and, you know, I think there was also an issue with some of the funding too, is that that money ended up being earmarked, that there was less money than to the Clean Water Fund loan after the infrastructure bill, because a large amount of that money got earmarked for a couple of bridges in the state, which obviously we all, you know, recognize the needs for those infrastructure needs as well. But you know, it just, you now have all of these projects and needs there. And, you know, yes, I think there was a rush to try to get those applications in before those requirements, but those requirements expired and the next round of applications were even more. So the need is there. And, you know, I just personally at our utility, we didn't have very many pipe breaks or, you know, joint failures or things, sinkholes forming. And in the last few years, they're happening and stuff is starting to fail. I mean, if you look at most of our, more than half of our infrastructure, especially gravity sewer pipes, were put in the 1960s and 70s. And that pipe now is average 45 to 65 years old. And, you know, life expectancy, we would say usually 75 years, you know, we're probably going to be hitting that end of the useful life. That's a large amount of infrastructure that's starting to fail. And, you know, this morning I was out doing inspections on manholes that were installed in 1916. So we still have even older items that we're trying to program in and rehab and replace. So I don't see that, you know, I don't think it was just oh, we think we might get funding now. As far as those project applications, I don't think this is going to go down by any means.
Yeah, I don't think there's a lot of push either, because a lot of these contaminants don't necessarily cause acute symptoms right away. You know, they're long-term issues, including PFAS, lead, these sorts of things. And especially lead, they seem to hit more impoverished areas, you know, lower income areas. So people unfortunately don't maybe pay as much attention to that area, as unfair as that may be. So I think that's why maybe we haven't seen as much public push for some of this here.
Or they're, as in Deanna's example, they're a renter. So, you know, there's just, it's challenging, you know,
Right.
and, you know, wastewater perspective, right? You also, you know, private laterals too, sanitary sewer laterals and the I&I, and, you know, if it's not really causing a problem to the person, you know, it just doesn't get addressed.
Great to know. Thank you all. Deanna, I would love to hear from you. What advice would you give to this audience on advocating for safer water for themselves, their communities, all of Wisconsin? You are on mute, Deanna. I don't know if you were trying to answer that or not. Unfortunately, we might not be able to hear you. If you're able to put an answer for that in the chat, that would be great. I know this audience would love to have that information. So I will go to another question. What do you wish that the public knew about their drinking water and wastewater infrastructure that it seems like they don't know?
I think maybe people shouldn't take it for granted, right? Because it's as simple as turning on a faucet or flushing a toilet and magic happens. You either have water or it goes away, right? And that's what happens 99.999% of the time. And only when that doesn't happen is when it becomes a concern. And there's a lot of work that goes into maintaining the systems to make sure that there's, you know, plentiful access to safe drinking water, and there's the ability for, you know, wastewater to go away somewhere where it's going to be treated and put back into a body of water cleaner than where it started.
I think they should understand that wastewater, drinking water, utilities around the country, we're all trying to do the same thing they want, which is to provide clean water for drinking and clean water to put back in the environment. Sometimes I think the industry, at least on the clean drinking water, or the wastewater side, I should say, the wastewater industry is viewed as the cause of all these problems. But we're really the ones that are giving that last cleanup to some of the dirtiest water that's out there before we put it back in the environment. So a lot of our social media and outreach is really to try to educate people on the importance of good, strong water and wastewater infrastructure.
I think I'd also encourage people, you know, children, older children maybe are coming into adult age, is to maybe look into careers at a local municipality. The median age of water and wastewater laborers is ever increasing. I think that's a common sentiment across most blue collar jobs. We're gonna need, there's gonna be a need for quality, educated, you know, motivated, ambitious people who want to get their certifications and, you know, work as a certified operator in both the water or wastewater realm of things.
And I would just say, I think we really need people to value water. And I think when I hear about, yes, you know, service charges are rising. But if you really think about, I think the average in our region is, you know, $450 to $500 per year for a homeowner. My family cell phone bill is almost $400. You know, so it's like, why do we, you know, when you put it in that perspective, we're getting tremendous value. I mean, water is essential. It's essential for society. I mean, until sanitary sewage treatment, you know, the plagues and, you know, I mean, you have to make sure that you're ensuring public health and the environment for society to function.
Absolutely. Value the resource, value the hardworking people, keeping you safe. I want to.
Water is cheaper than dirt if you do the volumetric cost.
I want to say that we have a great audience who's putting so many wonderful technical questions in the chat. Unfortunately, we only have time for each of our speakers here to give their one last pitch. What do you want this audience to come out of this webinar with? What do you want to mobilize us to go do? Kevin, let's start with you.
Oh, great. You know, I think I have a lot of faith in the wastewater utilities in the country. And I think as we are experiencing climate change, a lot of the negative impacts that we're going to see from climate changing can be addressed through water systems, drinking water, wastewater, stormwater. And I really have a lot of faith in the people that are doing the work, the hard work that we're all doing. So I think it's important for everyone to understand that the climate's changing. We have to do something about it. And wastewater utilities, at least in my world, is a place to start.
Perfect, thank you. Let's go in opposite order of the presentation. So Jen, if you're ready.
I'm going to go with the people theme as well. And we need more engineers, and we need more engineers here in Wisconsin. So advocate too for adding 1,000 more engineering students at UW-Madison because I gave a presentation for ASCE. I went to the local chapter and asked people to raise, or the students to raise their hands. More than half were out-of-state students and they were not planning to stay here in Wisconsin. So I think, you know, it's concerning, I guess, for me as an alum of UW-Madison who, you know, I grew up in Wisconsin and I went to school here, I've stayed here, I very much care about what we're doing as for water and wastewater. So I do think that that is also something to advocate for is funding for education to make sure that we have the quality developed workforce.
Absolutely. Thank you. Deanna, what would your last pitch be?
I invite everyone to help our church website, helpwiththe100.com. That's HEPHATHA for information on meetings about lead education, events going on in the community. Helpwiththe100.com. Thank you.
Thank you. Justin, you've got the pressure of being the last pitch. Bring us home.
Well, they already said everything I was gonna say, so, but maybe the one last thing, if you haven't been informed or haven't tested your water, or looked at the water pipe entering your house, go check, see if it's made of lead. You know, if it's magnetic, it's not lead. If it's plastic, it's not lead. If it's dull gray and you can gouge it with like a nail, it's probably lead. So you may want to look into, again, point of use systems, flushing your water every morning before you use it to avoid drinking the water that's sat adjacent to the lead overnight, sort of thing. So just be cognizant and wary of what you're drinking and do a little self-investigation here to kind of help yourself.
Perfect. Thank you all so much. We have a few closing remarks by our moderator, Ann Batista.
Well, thank you so much, Anastasia, and thank you to our audience for your questions. Special thanks, of course, to each of our wonderful speakers, Justin Bilskemper, Deanna Branch, Jennifer Hurlebaus, and Kevin Schafer for your excellent presentations and your really thoughtful responses to questions today. Thank you also to the American Society of Civil Engineers, Wisconsin chapter, and the League of Women Voters of Wisconsin, who provided planning and support for today's webinar. A special thanks again to Anastasia Soluna, President Dorothy Sky, and Executive Director Deborah Cronmiller from the Wisconsin League, and to Carl Sutter and Ken Micah from the ASCE Wisconsin chapter for all their work behind the scenes. A special thanks to Carol Diggeman for all her efforts to organize this series. I'm sure Carol has contacted each of our speakers multiple times. Thank you all for being with us today. The next webinar in this ASCE and LWV Wisconsin infrastructure series will be on broadband and energy on January 23rd. That will be the 6th of 9 webinars in this series. Information to join the 4 remaining webinars and to view the earlier webinars and this video today is posted on the Wisconsin League website, and I believe also on the ASCE Wisconsin chapter website. Thank you all again for joining us today, and Happy New Year.